Hello everybody. Today I want to go over how to make a maze game in Greenfoot. So there are a couple different ways to do mazes in Greenfoot. The easiest way to make a maze is to go into a drawing program. For example, I went to a site called autodraw.com and I can draw a whole bunch of rectangular boxes and fill them in, and I can make a maze that looks like this. Um, and I can use that image in Greenfoot, and I can program it so that my character can't go through the walls. The other way I could do it too, though, is I could actually go into Greenfoot and I could make a wall class, and I could make a wall stretch to be a long way. The difference between those two things is that if I make a wall class, a wall is an object, and an object can interact with my character. So I have PacMan here, and I could just put a whole bunch of walls on the screen, and then I could check to see if PacMan collides with the wall, and if he does, I could say, hey, you're not allowed to go through the wall. So I guess the problem, there's trade-offs. If you do it this way, the whole thing is just an image, and you can't interact with every individual wall, which means that you have to code your program based on the color of the background, which is doable. But we've already learned how to do collision detection, and so setting up your Greenfoot to have a whole bunch of objects that are wall objects, it could be considered easier. Now what I'm going to do in this little video tutorial is I'm going to show you both methods, because what I've done is I've kind of combined both of those. So I'm going to show you how mine works first. And basically what you're seeing here, you have to look carefully, is sort of the image I drew. So here's the image I drew, but notice there's a hole here, and also notice that there's no line in the middle. But if you go look at my Greenfoot game, there's a line here, and there's a line here. And if you look really closely, you can see there's a little bit of white there, which looks a little bit shady. It's not, kind of gives it away that this is a different kind of wall. So why is that? Well, here's how my game works. So I'm PacMan, and I'm going around the screen. I'm bumping into the walls to show you that I can't get through. And ultimately, I realize I've gone the wrong way. And you can see, yes, and by the way, yes, PacMan is sort of in the walls, and that's just, we're going to accept that for now. It's fixable, but we're going to accept that for now. Good enough, you can't get through. And if I pick up the cherries, watch what happens. Boom, that wall disappears. And now I'm going to go get that orange and watch what happens. Watch carefully the bottom right-hand corner of your screen when I hit the orange. And now an exit appears, and I can go down here, and I can go to the next world. So how is this done? Well, we're going to take a look at a couple of classes. We're going to look at my world, and we're going to look at PacMan. And believe it or not, that's really all that we have to look at. The other things, the cherries, the orange, the wall, the exit, are just pictures that sit there, and we're allowed to collide with them, and we scale them, but there's really nothing too exciting in there. So let's start by looking at the world. Now, when I go to the world, what you see is, firstly, this line of code here. And what this line does is it scales the background. So the background of the image, or of the world, sorry, is this image right here, which is the maze that I created. So I created this, I took a screenshot of it, and this is the image that forms the background of my world. So this code here takes the background image that I selected and scales it to fit however I wanted it to be. If I were to take one of these numbers and change it for whatever reason, you can see it changes the background going into the world. So I'm not going to do that, but that's how those numbers work. So that line is meant to change the scale of the background, that is the background of the world. And then up here you can see I have a whole bunch of objects that I've made. I have a couple of wall objects, one's called W1 and one's called W2. And then I've got PacMan, and then I've got an exit. And so these lines are just meant to add those things onto the screen. Excuse me. And I scale each of the walls that I put on. So just to show you how that works, if I were to scale this wall to be something totally different, if I put 120 here, that scales that wall to be 120 wide. And so I'm just showing you how the code is affected. I'm scaling the wall to be really thin, but really tall. So that right there is a wall object, and then that right here is a wall object, and the rest of it is the background that I've made in that paint program online. Okay, so that's pretty much all there is to the world. So the rest of the code is in PacMan, and there's quite a bit of code here, but what you'll find is it's somewhat familiar and it's very repetitive. Okay, there are some new things I'm going to run you through, but a lot of it is familiar. So firstly, PacMan has a move value that I've set to be 3. If I change that value to be 5 or higher, then PacMan's going to go faster. If I change it to a 1, PacMan's going to go slower. And here's PacMan's constructor, and I can tell that it's a constructor because it's a method that has the same name as the class, and notice that it doesn't have anything here. It's just public PacMan, whereas all the other things are public void. And so anyway, that's a constructor, and it says PacMan, I want you to be this size. That's just scaling the image to be 18 wide by 18 high, 18 pixels, that is. So now we get to the act method, and in the act method, what you see is familiar. If you hit the left key, then we're going to move. If you hit the right key, we're going to move. But it looks slightly different. Usually if we hit the left key, we change the location by subtracting from the left coordinate. So that's familiar, and that's familiar, but we have some things here. And these are what we call methods. And basically what I'm doing here is I am checking to see if PacMan hit the background wall, and I am checking to see if PacMan hit on any other wall. So I have to do a check to see if PacMan hit the background wall, the one that's kind of just based on color, the one I made in the paint program. But I also want to check to see if PacMan hit the wall that I can move around, this one, the one that I added to the screen. It's an object in the world. So there's 2 different checks that I have to do. So when I go back to PacMan, there we go. I'm going to say let's start here, and I want to check to see if PacMan hit the background wall. So I already talked about how we have to do this by checking the color of the background where PacMan wants to go. So if PacMan wants to go left, that means he wants to go this way. I want to check to see what the color is if I go that way. And that's exactly what I'm going to do here in this method. This is what's called a method, and you can take some time and read through the comments I put here. And what it says is I'm going to check to see what color the background is depending on the direction that PacMan is going right now. So you'll notice here, this is what we call a method call. I'm going to use the check for background wall method, but I'm going to include the L, which indicates that PacMan is trying to go left. Okay, so when we go back down here to take a look at this and how it works, you'll see that there's something called a color object. So I'm starting this color object, which is like a variable, and I'm just saying, okay, we're going to be using a color, and at the start of this, we're going to set it to be nothing. We haven't got the color quite yet. And then what this says is if the direction that was given to me is left, then we are going to get the current world, get the background, and we're going to get the color that is at the location that is just to the left of PacMan. So if you look at this, it says get the color at these coordinates. And if I subtract from the x coordinate like I am here, that's saying get me the color from the left side of PacMan. And if we go down here, so this is saying if that dir variable here is r, that means that the user who's running this, they want to check to see what's the color of the background to the right of PacMan. And this is saying what's the color of the background below PacMan. And this is saying what's the color of the background above PacMan. So in every case, basically, we look and see where's PacMan, and we check the color either left, up, down, or right, depending on the value of this dir thing. And we'll talk about that a little more in a minute. So we get this color object, right? Now here's the thing, and it's very complicated when we do mazes based on color. I have a little utility here on my Mac called Digital Color Meter, and I can hover over any area of the screen and it will tell me the RGB values. And what looks to me like black, true black, is an RGB value of 000, which means that there's absolutely no color involved. But if I hover over these things, what looks to be black, you can see is not necessarily black. It looks black to us, but to the computer, it's just a very dark shade. And so when I hover over white, you can see it's 255, 255, 255, meaning that there's full red, full green, full blue, and that makes the white. But here, what looks to be black isn't quite true black. Okay? And that is problematic, because what we want to say is if we run into a black color, don't move. But unfortunately, it's not quite that easy. What we're going to have to do is just say if we run into a dark shade, don't move. And so here's how we do that. I've got the color, I detected the color, so I'm storing the color in C. I've got the color stored in C after I do this check. So down here, what I do is I get the red value from the color I detected, and I'm going to store that as an integer called R. Then I get the green value excuse me, from the color, and I store that in an integer called G. And then I get the blue, and I store that in an integer called B. So I've got the individual RGB values. And here I say if the R value is below 30, and if the green value is below 30, and if the blue value is below 30, to me, what that means is we just hit a wall. We hit a really dark shade. And if we hit a wall, then what we're going to do is we're going to return a value of true, meaning, hey, we just hit a wall. But if we didn't, that means we're not going to return a value of true, which means we're going to get to this line of code and we return false. So in every single case, we're detecting the color. If we hit a dark shade, we return true. If we don't, we get to this line and we return false. And now that we go back up here and take a bit of a closer look here, you can see that this method called check for BGWall returns a Boolean value, which means that this method has to return a value of either true or false. So when someone decides they want to use this method, they have to include the direction that PacMan's going. And when the method runs all the way through, it's always going to return a value of either true if a wall was hit, or false if a wall was not hit. And that's what that word right there means. So if we go back up here, what we're saying here is use this method, and this is going to return either true or false. This exclamation mark right here stands for not. So what we're saying here is if we did not hit a background wall. In other words, if this returns false, that means we didn't hit a wall. And if it returns true, it means we did hit a wall. So if not hit a wall if not hit a background wall, and if not hit the other wall, then we can move. But if what happens is either one of these returns that, oh, we did hit a wall, then we're not allowed to do this, meaning we can't move. Now, I haven't gone over this one yet, but this is very, very similar. This one here, this method checks to see if we hit a background wall based on the color. This one is going to check on an object, because the problem is these walls here, this one here and this one here, they are not part of the background. So if I detect the color of the background right here, you might think it's black because we see a black wall, but it's not actually part of the background. the color there would actually be white. So we can't do it the exact same way. So I have another method that's going to work very similar called check for other wall. So if I go look at that method, which is a little bit lower down here, this one here works very similar. Depending on the direction of PacMan, it's going to check to see if we hit a wall. So at the start of this, we're going to start by making a wall variable, an object that says it starts at nothing. So we're going to assume that we didn't hit a wall. And then if the direction of PacMan is L, if PacMan's trying to go left, here is where we detect if there's a wall to the left of PacMan. This is a method called getOneObjectAtOffset. What this is actually quite similar to things we've done before, like Minecraft, and it's coordinate based. So the move value of PacMan is 3. So this says we're going to look -3 and 0 away from where PacMan is right now. So this is like a relative coordinate. If my coordinate's right here, see PacMan right there, if you want me to look -3 away from PacMan in the X direction, that means I'm going to look that way. 3. Oops, lost my place, sorry. And the 0 means you're not changing the vertical because we're only looking left. To look right, what we're doing is we're going to look +3. So that means look this way and see if we've hit a wall. If PacMan's trying to move down, now we're not changing the X. We're only looking down in the +3. So this would go, hey, is there a wall down here? And this one, because it's negative, would say, hey, is there a wall up here? So depending on the direction, this checks a bit away from PacMan using what we call an offset and checks to see if there's a wall where PacMan is trying to go. If there is a wall, so I'm down here, if there is a wall where PacMan wants to go, then we return true, indicating there's a wall in the way. If not, then we return false. Very, very similar to what you saw here in the other one. So these two methods are very similar. It's just that here we're actually seeing if we're going to collide with a wall object, whereas in the other one we were checking the color where PacMan was trying to be. In either case, what happens is, based on this code, if it is true that if it is not true that PacMan hit a background wall, so if PacMan didn't hit a wall, a background wall, and if it is not true that PacMan hit a different wall, an object wall, then we're allowed to move. If either one of these conditions is true or is false, if we actually hit a wall, it won't let us move. These double negatives are tricky, but basically what this is saying is if we hit either kind of wall, we're not allowed to run this code, meaning that PacMan will not move. And that's why you see this behavior. If I run it and I try to go down, over, up, I didn't hit a wall, I'm okay. I didn't hit a wall, I'm okay. I didn't hit a wall. And now it's detecting color. So it detects that, oh, there's a color of black where I'm trying to go. So even though I'm pressing up right now, it won't let me go. And if I try to go to this wall, which is, so this one was a background wall, so this isn't letting me go because of the color, but now this one here won't let me go because it's detecting a collision with a wall, and it won't let me go because of that. And then when I hit the cherries, actually we didn't quite get that far here, so that's movement. And then here is collision detection. So this says, let's check to see if we've collided with any of these objects, cherries, orange, or exit. So if you do collide with the cherry, remove the cherry and remove wall 1. So wall 1 is this one right here. So as soon as PacMan hits the cherry, it removes wall 1. And then once we hit the orange here, We remove the orange, we remove wall 2, which is the one in the bottom corner, and we add the exit picture to the screen. So here, now here's a little trick. The exit picture is nothing more than a white space. It's a picture of white. So right here, it looks like a hole just appeared, but I put a picture of a white space. Why would I do that? Well, because in order to get out of the maze and move on, I need to be able to collide with something. So even though it's white space and it doesn't look like anything at all, when PacMan gets to this point, if you look at the code, it says if PacMan collides with the exit, then we set world to next level. And so PacMan is going to, what to the user, to people that actually do mazes on paper, it looks like PacMan is just going to get out of the maze. But what's really happening is PacMan is colliding with a picture of white. And so right there, it collided and we go to the next level. Phew, that was a lot. So what you've seen is how we can detect if PacMan hits a wall by basing it on the color of the background. So you can actually go and draw your own maze and just detect if PacMan is going to get through the walls based on the color of the background. Or you could just make a wall object and put a whole bunch of walls and just detect if PacMan hits those walls based on collision detection. You can do it either way. So I hope that explained quite a bit about how to make a maze using Greenfoot, and have a great day.